In the following two videos, we will talk about how to create random access files. We can read and write the data into that. So to create a random access file, the fundamental thing is we need to know what kind of data we want to save. So we will create the data we want to save as an object. So as you know, for the object-oriented programming, the same type object, actually they have the same fixed length for each object. So using the same size fixed length record, so we can calculate the size of the data. Then they kind of just like the array, they will save one by one. So you can using the size to calculate the specific data where they're located. And also remember earlier we talked about for the file reading and write, we have the file pointer. So since we can calculate the size for the object with the index, so we know where we should go to access that data. So the random access file, just like earlier we say, you still have the data one by one. For example, this one we have a student object. So we just say, for example, student object, each object, they are 100 bytes. So that's why you will see here, since they have fixed size. So we have 1, 2, 3, 4, 5, 6 student object. So when we want to access the fifth element, yeah, we can easily to calculate, right? So then you will see here, they were using the start from the byte is 0. So then 100 is the first one, 200 is the second one. So the fifth object, we know they are from the byte 400. So then we can access this object to update the data, or we want to retrieve the data. So that's random access file. So when we create the random access file, the same thing, you have your object you need to create. So since data can be inserted into a random access file without destroying other data in the file, so then we will pre-allocate all the data. So then when you create the object, we will create an F string. So not IF string, not the OF string, because when we try to create the random access file, we're using the F string because we can either read and write at the same time. So then here, the same thing, you will specify your file name. So then here, we will specify IOS is the binary access. So after you have the file string object created, you specify the file name. So then we can access the file, either read or write. But the most important thing, like earlier we said, we need to create an object. So once the object being created, so we were using the default constructor to create the default object. So then they will allocate the size one by one. So when we want to write the object into the file, actually we were using the write function. From the all-string member function, we have the write. So this write output to the specific string with a fixed size of byte, beginning of the specific location. So when we want to read, right, so we also have the function we call read. They will input a fixed member of the byte for the specific location. So which location we should do? Remember, write, we're using the put. So then you will read, we're using the get file position pointer. One thing is, earlier, remember when we want to write to the text file, we're using the F string like cout. But here will be a little different because we will write not the string, we are write an object into the file. So that's why we need to use the write function. So after you know the location, we will write the information to the file. And also when you write, you also need to specify your data size. So the next one we see, for example, what is the write function. So for example, we will output a 4-byte integer. So then how will display? So then when you write the binary version for the integer for 4 bytes, that's how we'll do that. Like earlier we said, you have an string object. So then you try to write. So then the first part is your object type. So then the second one is the size for the data you want to write. So the data you want to write the size, we use the size of. So for example, now the data we want to write is a 4-byte integer. So this 4-byte integer, we just call the variable name is number. So then when you write, you see you need to give them the variable location. So then they will cast this location into a constant card pointer. So you can see constant card pointer is what? It's just a location. So then constant card is byte by byte. So that's why you will passing your object location. So then we will need to cast to the const character pointer, follow with your data size. So your function write, they treat the first argument as a group of the byte, right? Because why the group of byte? Because their memory location is constant cards pointer. So that's why they're using for the byte to read. So then according to the size, so they will allocate how many bytes when you write the information. So the same thing for your read will be the same. So you understand the write, the purpose is just reserve the size for the information in byte. So that's why since we don't know, we don't have the data type for all different kind of variable. So then we just cast that to the constant, like the card pointer. So then they will treat them byte and byte. So you reserve the size. So then we overwrite that size location with a different data type. So now let's create a random access file. So this random access file we will consider to create as the client data information. So we will consider the problem is we want to create a client data program. They will store 100 fixed length record for each client. So each client record, they will have account number. They will have the last name, first name, and the balance. So then later when we access this file, we should be able to update account information. We can add a new account. We can delete the account. Or we can insert the account record into a pre-formatted text file for the print. So that's what we'll do in the case study. But the first thing is we want to ask, how should I create a random access file with 100 fixed length record? So that's why the first thing is we need to have the record we want. So we create the client data class. So this client data class, like earlier we said, they have 4 attributes. They have account number, we use the int. They have the first name and the last name. The same thing, we need to know the size for the data. So that's why each first name and last name, we don't use the string. We're using the character array. So your first name, we can at most have 10 letters. So then your last name can have 15 letters. So the balance is double. And you need to remember, when you create this kind of data, so you need to make sure the data, the object have the default constructor. So that's why the constructor, we will pass in the account number, first name, last name, and the balance. You see they always the default value. So that's why we can have the default constructor. Of course, they have all the getter function and the setter function. So the next example I just show you here. Actually, this one you will just see by yourself by detail. So then the first thing you have the client data class header file. Like earlier we said, you have 4 private data attributes. You have default constructor. So all the getter function, setter function, you all have that. So this one is header file. So your CPP file, the same thing. Since you implement so many different CPP files, so you know the getter function will get the information. The most important thing for your setter function, like the last name, we say we only can have 15 characters. So that's why here they will check. Whenever we have a new last name, we need to make sure the size fits. Otherwise, we just truncate that. Same thing, your first name, you only can have 10 letters. So we will see how we will make that. So now after you have your client data, right? So you have your object created. So now we will see how can we really create our binary file with 100 client data. So make sure download your clientdata.h header file and clientdata.cpp file. So now in our driver program, the example 4, that's our driver program. So that here we include our clientdata.h file. We still have IOString include and FString include. So now the first thing we see line 16. That's how we will create our binary file. So usually .txt file means that's the text file. So when you're using the .dat, that means that's a binary file. So when we create the binary file, this one you can using the FString. But here, since we try to only write the default object into the binary file, so we're using the OFString. So when we create that, so you specify your file name. You specify you want to write to the file. And don't forget, this time we will write as the binary file. So this one is still the same thing. If you cannot find the file, print the error message. So now that's write 100 default client data object. So that's why in line 25, what does that mean? You see, you create a client data object called blank client. The blank client, did they create the object? They did, because this one is we create, we're using the static memory to create a client data object. Since you didn't specify, that means they call default constructor. So when they call default constructor, that means all the data attribute, your first name, last name, your balance, and ID, they are all equal to 0. Here, we only need the default constructor. Why? Because the purpose is we just want to reserve the data. We allocate the object data in our binary file. So now you say you want to write 100 blank record, right? So that's why you see we just do that 100 times. So every time you will be using our OFString dot write. Good. Remember how to use the write. The writes expect 2 arguments, right? So the first argument is your object reference. Then we cast into the constant character pointer. So that's we use the reinterpret cast to cast this object type into the constant character pointer. So then don't forget, you need to specify the size of your object. So this one just give them the static object variable name. So afterward, then you create a binary file. So after this program work, we run this program successfully, what happened? Right, this credit.dat binary file will be under your working folder. So after you find this file, you double click, what did you see? So after you run this program, what did you see? Nothing, because nothing you print. But if you go to see your working folder, then you will see you have a credit.dat file. So this credit.dat file, actually they are the binary file. So you try to double click on that. Actually, nothing will happen because you cannot really can get that, the value. You cannot really can see the data. They are the binary file. You try to using a text editor to read that, nothing you can read because that's a binary file.